Hello. So today we'll be doing the problem called right view of a binary tree. So basically, given a binary tree, return an array containing nodes in its right view. The right view of a binary tree is 7 nodes visible when the tree is seen from the right side. So I drew out our tree here, right? And so assume like all the nodes are exactly the same size. So when you look at it from a perpendicular standpoint, right? So like let's just assume we're currently parallel with this and you see the whole tree. If you look at it like from a perpendicular standpoint, you'll only see, certain nodes. And so if we go to the right side, we would only see 12, 1, 5, and 3, right? And so that's basically just the problem. It's relatively simple. So we'll go ahead and implement this question. So, the very typical base case is if not root, which basically just means if root is not, if it is none, then we'll just return an empty array because there's nothing to return. And since we want to return a list of tree nodes, we'll just return an empty array, right? And so with that being said, we can start building out a solution. So our result will be an array. You could also, put this up here and then return res, and you don't have to, I guess, initialize it afterward, but I don't know, it looks kind of weird. So we'll just do this. I guess it's because if you do this, you also like hold like a variable, right? I mean, this also should initialize some space, but I don't know, not too sure. From there, but then, basically for the purpose of this solution, we'll just return an empty list initialized here, and then we'll initialize a result array or res array when we know we have at least one node. We'll create a queue using dequeue again. Queue.append root, because we now know that root is not none. And so when we do that, we'll just have a while loop that basically goes through every level, and then we will build out our solution. So while the length of queue is not 0, then we'll initialize a length variable, which is just the length of the queue. And then for I in range of length, we're going to go through the array, right? And then this is the part where we traverse per level, and we need to take out everything. Node is equal to q dot pop poop left works too, I guess. Pop left. Node is equal to q dot pop left, and then because we need to pop out every node until the last one, right? And then that's what we'll add into our result array. And so we'll do if I is equal to the length minus 1, which means this is like the last one, right? Because here we get the length of what our current level is at. We store the length, and then that's what we're iterating through. Like that's the number that our range is based off of, right? So if length minus 1, that means we're in the last one. We want to append that to our result array, right? And then here we got to build out the rest of the levels as we go through each node. So if node.left, this just means if node.left is not none, then we'll do q.append node.left. If node.right, same thing for node.right, q.append node.right. And then here we'll just return result or res, because there's nothing else for us to do here. And so if we look at our tree, we expect 12, 1, 5, and 3, right? So if we run it here, we get 12, 1, 5, and 3 for the 4 levels. Yeah, so that is our solution for right view of binary tree. Thank you for watching. Come again next time.